Hello students. Welcome to Varun Tutorials. Let's solve the third problem. If the air is maintained at 15 degrees Celsius and the temperature of the body drops from 70 degrees Celsius to 40 degrees Celsius in 10 minutes, what will be its temperature after 30 minutes? Let us solve it step by step. Let the temperature of the body at any time t be theta. By Newton's law of cooling, we have d theta by dt equals minus k times the quantity theta minus theta 0, where theta 0 is the temperature of the air. Substituting the air temperature theta 0 equals 15, we get d theta by dt equals minus k times the quantity theta minus 15. Separating variables, we write d theta over theta minus 15 equals minus k dt. We label this as equation 1. Integrating both sides of the equation, we get the integral of d theta over theta minus 15 equals minus k times the integral of dt. Recall that the integral of 1 over x minus a is log of x minus a. Integrating, we obtain log of the quantity theta minus 15 equals minus kt plus log c, where c is the integrating constant. Subtracting log c and taking the exponential on both sides, we get log of theta minus 15 over c equals minus kt, which gives theta minus 15 over c equals e to the power of minus kt. This simplifies to theta equals 15 plus c times e to the power of minus kt. We label this as equation 2. We are given the initial conditions: when t equals 0, theta is 70, and when t equals 10, theta is 40. First, let's substitute t equals 0 and theta equals 70 into equation 2 to find the constant c. This gives 70 equals 15 plus c times e to the 0 power. Therefore, c equals 55. Now, let's substitute c equals 55 in our second condition, t equals 10 and theta equals 40 into equation 2. This yields 40 equals 15 plus 55 times e to the power of minus 10k, subtracting 15 from both sides gives 25 equals 55 times e to the power of minus 10k, dividing by 55 gives e to the power of minus 10k equals 25 over 55, which simplifies to 5 over 11. We label this as equation 3. Let's find the temperature theta of the body after 30 minutes. Substituting t equals 30 into equation 2, we get theta equals 15 plus 55 times e to the power of minus 30k. Using the laws of exponents, we can rewrite e to the power of minus 30k as the cube of e to the power of minus 10k. Substituting equation 3 into this expression, we get theta equals 15 plus 55 times the quantity 5 over 11 cubed. Evaluating this expression yields theta equals 20.1653, which is approximately 20 degrees Celsius. Therefore, the temperature after 30 minutes will be approximately 20 degrees Celsius. Let's solve the fourth problem. A body kept in air with temperature 25 degrees Celsius cools from 140 degrees Celsius to 80 degrees Celsius in 20 minutes. Find the time when the body cools down to 35 degrees Celsius. Let us solve it step by step. Let the temperature of the body at time t be theta. By Newton's law of cooling, we have d theta by dt equals minus k times the quantity theta minus theta 0, where theta 0 is the temperature of the air. Substituting the air temperature theta 0 equals 25, we get d theta by dt equals minus k times the quantity theta minus 25. Separating the variables, we write d theta over theta minus 25 equals minus k dt. We label this as equation 1. Integrating on both sides of the equation, we get the integral of d theta over theta minus 25 equals minus k times the integral of dt. Recall the integration formula for 1 over x minus a. Integrating, we obtain log of the quantity theta minus 25 equals minus kt plus log c, where c is the integrating constant. Taking the exponential of both sides, we get log of theta minus 25 over c equals minus kt, which gives theta minus 25 over c equals e to the power of minus kt. This simplifies to theta equals 25 plus c times e to the power of minus kt. We label this as equation 2. We are given that when t equals 0, theta is 140, and when t equals 20, theta is 80. First, let's substitute t equals 0 and theta equals 140 into equation 2 to find the constant c. This gives 140 equals 25 plus c times e to the 0 power. Therefore, c equals 115. Now, let's substitute c equals 115 in our second condition, t equals 20 and theta equals 80 into equation 2. This yields 80 equals 25 plus 115 times e to the power of minus 20k, subtracting 25 from both sides gives 55 equals 115 times e to the power of minus 20k, dividing by 115 gives e to the power of minus 20k equals 55 over 115. Taking the reciprocal, e to the power of 20k equals 115 over 55. Taking the natural logarithm of both sides gives 20k equals log of 115 over 55, which yields k equals 1 over 20 times log of 115 over 55. We label this as equation 3. Now, let's find the time t when the body cools down to 35 degrees Celsius. Substituting theta equals 35 into equation 2 gives 35 equals 25 plus 115 times e to the power of minus kt. Subtracting 25 from both sides, we get 10 equals 115 times e to the power of minus kt, dividing by 115, we get e to the power of minus kt equals 10 over 115. Taking the reciprocal of both sides gives e to the power of kt equals 115 over 10. Taking the natural logarithm of both sides gives kt equals log of 115 over 10. Substituting the value of k from equation 3, we get 1 over 20 times log of 115 over 55 times t equals log of 115 over 10. Recall the relation between exponential and logarithmic forms. Solving for t, we get t equals 20 times the log of 115 over 10 divided by the log of 115 over 55. Calculating the ratio of the logarithms gives approximately 3.31. This simplifies the equation to t equals 20 times 3.31. Multiplying these values yields t equals 66.2 minutes. Therefore, the body cools down to 35 degrees Celsius after approximately 66.2 minutes. Thank you for watching. If you found this helpful, please like, share, and subscribe to Varun Tutorials. Turn on notifications so you never miss a new video.